All right, let's start moving forward to look at today. Now, really the second half of this chapter, how many of you guys, a lot of you already might have seen different parts of this chapter, but how many of you guys have heard of sine, cosine, and tangent, or seen those on your calculator? Sine, cosine, and tangent. Probably what you've seen on your calculator, maybe you've noticed it, like towards the middle, it'll say sine, cosine, and tangent, and those are different operations on your calculator. We're going to figure out, we will be getting to the calculator stuff, and we will need to grab a calculator for the practice and do those. But we're going to be looking at each of these operations and kind of what they do. Today we're just looking at the tangent ratio, and we're just looking at tangent. But as we go through this week, we're going to be looking at all three of them. So we've got a term, example, and I even said log in the class cake, but I never made it. You guys are off the hook. Before we look at it, what does the word perspective mean? Not necessarily in math, but just in general. What is the word perspective? Or describe it in a situation, or tell me a little bit about it. Cole?
The way you look at something different.
Yeah. Mm-hmm. Anything else to add? Right? If Cole and I are looking at Will, Cole has a different perspective of Will than I do of Will. Right? We both look at Will from a different view, look at Will differently, right? When we look at cosine, sine, and tangent, we need to kind of have a certain perspective in mind, because each of these different terms, each of these different processes, look at a triangle in a little bit of a different way. And today we're going to look at the way that, like, a tangent, or from the perspective of a tangent, and we'll have to keep in mind always what our perspective is. Is our perspective from angle B? Is our perspective from angle A? And we're going to have to keep that straight, because otherwise it's going to be a long unit if we don't keep straight where we're at. Here's the definition of tangent. Now, how many of you guys have seen this symbol before? Not quite. No. Do you know what it is, Hannah? No, you've seen it, but not sure what it is or what it's called. That is the theta symbol. So when we are looking for different angles, theta is, I think it's a Greek something. But if our perspective is from angle A, you might see that theta is at angle A. That means we are looking from angle A. That everything we do is coming from the perspective of angle A. Now, we also could just call it angle A, but you might hear me say, theta is at angle A, or in your textbook you might see that symbol. So don't let it freak you out. That's just saying where we are solving from. So let's say that we are looking at, well, first let's label our triangle. We have the hypotenuse, we have a leg, and a leg. So when we are talking about tangent, we take whatever perspective we're looking from, wherever theta is at, and it is the length of the opposite leg over the length of the adjacent leg. Does anyone know what the word adjacent means? Next to, yeah. We could say that Jack is adjacent to Chaz. That would be a legit thing to say. So if we are going from the perspective of angle A, right here, who can name what leg would be the opposite? What would be the opposite leg from angle A? BC. What about the adjacent leg? Yep. We're looking now, changing perspective, and looking from angle B. What would the opposite leg be? AC over BC. Good. Yep. So whatever perspective we're working from, whatever we see in these parentheses makes a big difference on what our tangent ratio is. Now, we'll be able to use this tangent ratio to find the different lengths of triangles, different lengths of sides, and to find the actual. That kind of looks like a smiley face. Isn't that kind of cool? That was on accident. What was I saying? Oh, we'll be able to use tangent to find the length of legs, length of the hypotenuse. Well, not the length of the hypotenuse. Just kidding. And the length or the measure of angles. Now, notice we have 90-degree angle every time, so we know that one of them, or we have to be working with a 90-degree triangle. But we can have like a 37.5 degree angle here, and we would be able to find angle A using the tangent ratio. I'll show you what I mean. So this question says, find the tangent of S and the tangent of R. Round, let's see, write each answer as a fraction, and then round the decimal to 4 places. So remember, tangent means, we think tangent, we need to know that it means opposite over adjacent. Opposite over adjacent. So if we're looking at the tangent of angle S, that would be from the perspective of S, what is the opposite, what is the length of the opposite side? 80. And then the adjacent side is 18. Does anyone have their calculator ready? 80 divided by 18, rounded to 4 decimal places. So what? Yeah, so something that you'll learn, that you probably are starting to see in math, and what you'll learn is that they say, like even as you get to upper level math, that 4 decimal places is kind of the standard if they don't tell you. 4 decimal places is considered accurate and all that good stuff. So no more rounding to the tens. Sorry. 4 decimal places. Good. So the tangent of S, or the ratio of this opposite side to the adjacent side, is 4.4 repeating. How about the tangent from the perspective of R? Yeah, opposite over adjacent. And what does that give us when we plug it in? Hi, Mrs. Shoup.
Hi.
What can I do for you?
Opposite over adjacent. That's my thing.
Yes.
Yes.
I found this in the
Was it in there?
yes.
Okay, sorry.
But thank you. No, thanks for walking
Yeah.
it over. There's 15 questions total.
I don't know. I rewrote that last year.
Okay.
It's just kind of cut and paste.
Yeah. No, that's
If you
good.
want it pretty, feel free.
I might have started doing that this weekend. I was going to print it off to you as well. So, but thank you for walking that down.
Opposite over adjacent. Dad did a nice job at my place. You're welcome. Yeah. Yeah. Did you know he was working at my place?
No.
Would you talk to your dad?
I'm not sure.
Okay, will you talk to him tonight and say, Mrs. Shoup came in, specifically told me you did a nice job. Very good. Your mom is too, she cleaned my teeth last night. Huh? Sorry, Mr. Lamb.
That's all right. I'm learning all kinds of stuff. What were we talking about? Oh yeah, 18 over 80 as a decimal. 0.225. So if it asks you, find the tangent of a certain letter, that's all we're doing is writing that fraction or writing that ratio and putting that as a decimal. Think we can handle that? Hopefully, because here are 2 problems where you have to find the tangent of certain letters. Ready, set, go. Take 2 minutes to find the tangent of those letters.
I can find them in this. Oh my gosh. Oh, shoot. Hey, let's go. Paper out right now. Jason over
Let's see, J and K for each one. So we have 4. I would let people draw with the pen if they have answers here. If you have an answer and would like to write the fraction and the decimal on the board, well, on the iPad, please raise your hand. I'll get my attention. Did you guys get any of them? Really? So why don't you guys write one of them? Write the fraction and then write the decimal. You choose whichever one you want. Now we're going speed mode here. We're recording, so we gotta get it right. Give the fraction and give the decimal.
Is this from something?
Look, I already wrote the fraction and the decimal. Perspective angle J. Nice. What is that as a decimal? Perfect. Sure, you guys choose one of the 3 that are up. No, go ahead. Go ahead, choose one of the 3. Write the fraction and then get the decimal. Hey, I come over. You guys next. Write the fraction and write the decimal. You have either tangents of k, whichever one you want. 1 or 2.
Does my tangent raise before I do it for either of them? The first one.
Perfect. This is great. Write down that one. Good. Oh, they switched it up. They took the one that you were gonna do. Dang it. That was low. 2, J. Yep. Good. Then write that one down. Let's switch it up again.
You guys should just do like the rest of them.
Here you go. Then I'll need one more. I'm reading like somewhere right here. To do the last one.
I crawled like
Tangent press K.
I left some there, now it's less there, now it's way less specific.
Kind of going on.
Oh! Perfect. They shot the last one.
Boxes were
Tangent of K.
I'm not playing it,
You're not on your phone. That's still on your phone. That makes no difference.
well, I already
Let's go. Let's go. Tangent K. Yep. 15 over 8. Yep. We don't have the hypotenuse involved. We have the leg. Opposite leg over adjacent leg. Use the correction.
Right.
15 over 8.
Probably does. Oh wait, I own fractions too.
Probably just one. Perfect. So we would call all of these, thank you to those that were writing, we would call all of these the tangent ratios. And see, it's a ratio because we are comparing two things. We're comparing our opposite side to the adjacent side. Are we doing okay so far?
Yeah.
Okay. Now, good one? Now, we are going to use our tangent ratio to solve for a side. Now remember, we're going from the perspective of a certain angle. So in this case, we're trying to solve for x. We're going to go from the perspective of this angle, 32-degree angle right here. So we are finding the tangent of 32 equals, now from that perspective, what would our ratio be? 11 over x. Now if you don't already have one, you need to go go get a class calculator right now. No iPad calculators or phone calculators. Class calculator. No. There
You didn't even do anything. Bailey should be getting the calculator right now.
we go. Boom, roasted.
Allie, you're good. Look,
Did you see that?
yeah, I did see that.
Why did you not get them?
I look over for
So-
singing. Ow.
What we need to remember is that the tangent of 32 is just a number, okay? We'll find what that number is in just a second, but we know tangent of 32 is a number, just like pi is just a number. So knowing that, how would we solve for x here? Like what algebra strategy would we use to solve for x? Yes, Jack? Oh, was that a hand up and then a hand down? Okay, so someone besides Jack, unless you want to try it.
I guess what you could do is you could find the actual tangent of 32.
Okay.
And then you could divide that by 11.
Yes. Now, the way, the process that we would use to get there would be to cross multiply, is what I would look to do. So, but Jack is right. That is what we will end up doing. So we have tan of 32, or Jack is close, maybe not exactly right on, times x equals 11, right? That's how we would cross multiply. We look our cross products. Now to get x by itself, we know that x equals 11 over the tangent of 32. Now you're thinking, how the heck do I find the tangent of 32? Well, let's figure it out. If you go to your calculator and type in 11 divided by, now 2 rows above the letters, you should see sine, cosine, and tangent. Does everybody see those? 2 rows above, did I say 2 rows above the letters? 2 rows above the numbers, hello. You should see sine, cosine, and tangent written in white on black keys. If you hit tangent of 32, then it should give you 16 point.
413,004.
Yeah, good.
Yeah.
Now, if we look at our drawing, not that these aren't always drawn to scale, but if this side length is 11, is it believable that this is 16 point something? Probably. Yeah, if we got like 600 and something, we would know we were way off. If we got like 2.7, we would know we were way off. But 16 seems to make sense. So we just found, I don't know if you guys understand how insane this is. We just found a side length of a triangle without using the Pythagorean theorem. We've never done that before. We found the side length. Now, we couldn't use the Pythagorean theorem, right? Because we don't have the hypotenuse. With the Pythagorean theorem, we need at least 2 of the 3 sides. But now that they're giving us situations where they don't give us 2 out of the 3 sides, we can't use Pythagorean theorem. So this is where we go to sine, cosine, and tangent, what we're looking at today. Yes? Yes. We will look at, that's what we're going to end this chapter with, is 2 different laws that show us how we can find sides in non-right triangles. Very cool. Law of sines, law of cosines. We'll get there. Now, we're going to skip that. So now it's your turn. You have 2 problems. After only 1 example, let's see if we can find the value of x. I'll help you with the setup for the first one. So we're going from the perspective of 61 degrees. And then we have the opposite over adjacent. Shh. I don't know. No, it is not. there's your setup. Now you can cross multiply and solve.
Right.
Just a second. Everyone look at their calculator.
Calculator.
Look at your calculator. Look at the screen. On the very top in the gray, it says normal, float, auto, real, and then it says either radiant or degree. How many people says radiant? Yeah, we need to switch to degree mode. So if yours says radiant at the top, you will not get the correct answer.
That's nice.
Which, on the last problem, mine said radiant at the top. So we did not get the correct answer. That's my fault. If yours says radiant at the top, well, everyone should probably do this because you will have times where this happens. You need to change the mode of your calculator. So right next to the second button, don't hit second, but it's right next to the second button. Hit mode. And the fourth, hey, Brayden, and the fourth one down says either radiant or degree. We need to be on degree mode. So hover over degree, hit enter, and then quickly exit out of there.
Quickly. Don't touch anything else.
Do not hit anything else. Go to degree mode. Now type in, well, we'll move on from the last one, but now you can solve this one.
You just press enter.
Yep, you have to hover over degree, hit enter. If you did not get there, then please let me know, and I'll help you get there.
That's equal to 12.19.
Better than having I just 12.194. No, it's 1.10. Oh, I have no. I did 2 divided, never mind. Oh my gosh, Jack, you that way.
Oh, see, earlier they said round to the nearest 4 decimal places. Now we're going back to tenths.
Yes, I got it right.
So if your calculator's in degree mode, we should get 12.2.
What's the difference between degree mode and radian mode? What?
It does all kinds of when it comes to geometry and then you'll look. Yes, it is. Literally, I saw that your wheat needs to be.
I haven't played all week.
He had his work done.
What does that make a difference? Distracting you.
But I did
Wait,
it.
Cole has his work done?
I did it too.
Okay, so you don't have your work done. All right, let's go. Oh, did you guys get number 4 already?
I bet I could do it.
No, did you get it already? Because you guys were screwing around, so you must have gotten it already.
Jack must have gotten it because he was crazy.
Let's see, we have our opposite would be x over adjacent would be 13. Now we'll cross multiply.
Where's my can button go?
56 times 13 gives me x. And b, what was that again? All right, that's the biggest thing we're learning today. I need to show you one more thing, which there will be problems like this on the homework, but you will not have to practice this last thing. So this term comes up in this lesson, angle of elevation. All right, and this actually is a pretty good picture of it. So if you are standing here looking at, what do you want to be looking at in the sky? The sun, the moon, or a bird would make sense,
You don't
wouldn't
want
it?
to look at the sun.
Yeah, that's probably not the best thing. So let's say that we have Alton, and we have, oh, the bird needs to be coming to attack him. The bird's coming to attack. Coming to attack. It's not a satellite, it's a bird. Coming to attack Alton. Alright? Alton is looking up at the bird, waiting for it to come peck him. And if this is the ground, okay, or the horizontal line from like his eyes, parallel with the ground, and the angle looking up at the bird, we would call this the angle of elevation. Now, this is important because we could create a story problem with Alton and the bird. Alright? We could have from the object straight down to the ground, and we could find. Are you guys following with me or are you just laughing? Okay, sweet. And we could find, I'll draw it on here. Pretty much, exactly. But they like to call it the angle of elevation to make it a real life situation. So if I told you that from the bird straight to Alton, like on the ground, the horizontal distance was 26 feet, and the angle of elevation was 37 degrees, we could figure out using, well, not using tangent yet. We will be able to figure out what this hypotenuse is, or what, how far the bird is from attacking Alton. But angle of elevation, the point is that got way too specific and detailed from this weekend. But the point is, angle of elevation is from our line of sight to the ground. We will see that come up sometimes. And I will not go into this example. We will just stop it there.